All right, welcome back everyone. Let's go ahead and look at the solutions to the now you try problems where we are factoring polynomial expressions in two variables completely. The first expression we're going to look at is x squared minus 12xy plus 36y squared. What I recognize is that I have a square and a square at the beginning and the end. So I'm going to attempt and see if it works. If I put an x at the first positions, and then I have a 36y squared in the last term. So what if I try a 6y and a 6y? Then if I want the middle term to come out as a negative 12, if I put a minus and a minus in here, this will give us x squared minus 6xy minus 6xy again in the middle terms, and then a plus 36y squared. These do add up to negative 12xy, so we're good. And if I look at these, nothing factors x minus 6y is prime, nothing more can be done here. And so this x minus 6y times x minus 6y is really my final answer. I'm just thinking, I can write this as x minus 6y quantity to the second, like all of that squared, right? Because it's the same thing multiplied by itself, x minus 6y times x minus 6y. So we can write it in that way if we would like to. And one of those, it's not that one is right and one is wrong, it's just, let's try this next one. We have 4r to the 10th plus 4r to the 9th plus r to the 8th. And here, first thing I see is that r to the 8th can be pulled out of all of these. If I pull out that r to the 8th, I'm left with 4r squared. Right, I've pulled 8 out, so there's only 2 left in that first term, plus 4r. I had 4r to the 9th, so I took out 8 of those, only 1 left. And then if I factor out an r to the 8th from r to the 8th, I'm left with just a 1. Okay, and then I want to say, can I go any further, or am I done? Is that prime? Well, let's take a look. If that was the problem and we had nothing else, right, if we were just focusing in on the 4r squared plus 4r plus 1 and said, can I factor that? Oops. I would try opening up a couple of sets of parentheses, and I would note the perfect squares on the ends. So I might try a 2r and a 1 and a 2r and a 1. If I tried a plus in both of those, then I would have a 2r, or if I foiled that, I'd get 4r squared plus 2r plus 2r plus 1. Those do add to a positive 4r, so that's a good thing. That does work. Cool, so we can factor this, and I might as well write this in the abbreviated form of r to the 8th times parentheses 2r plus 1 quantity squared. All right, moving on to part squared times y cubed minus 10xy squared plus 8y. Look like looking for a GCF first. And the GCF 2 goes into everything. There's also a y in everything. So let's pull that out. We have 2y. We pull out. So if I pull that out of the first term, I'm left with an x squared y squared. Then a minus 10. We have minus 10xy squared. If I factor out a 2y, I get 5. The x is still there. Pulled out a y, so just 5xy now. Then the last term was plus 8y. If I factor out a 2y, that will be a positive 4. So 2y times 4 would give me an 8y. And the question is, can we go any further with that? Can I do any more with it? Let's try and just see what happens. My x squared y squared in the first term, I think that means I need an xy in the first position of both of my sets of parentheses. And then we need a 4 at the end, so I could do 2 and 2, or I could do 1 and 4. I'm going to use a 1 and 4 because they add to 5, which is what I'm trying to get in the middle term there. If I do a minus 1 and a minus 4, then I will get the middle terms let's see, if I FOIL this out, just to check, I'd have 2y, which I'm going to leave alone for a second, and I get x squared y squared, and then a minus 4xy, and then a minus xy, and then a plus 4, and then these do add to that minus 5xy there. So that does work. And so we're done. And when I say we're done, I mean this is the final answer. That next line was just a check to make sure that worked, because the xy minus 1 and the xy minus 4, you can't factor those any further. Those are completely done there. I do want to point out, as long as I'm thinking about it, xy minus 4, that almost looks like a difference of squares, but the xy is not a perfect square, so that wouldn't actually work there. In case that was something that popped into your head. All right, let's look at part D. This is interesting. X to the 6 minus 36y to the 4th. There's no GCF. That's the first thing I'm checking and thinking about in my head. So I can't do that. But I can think, okay, could I factor this? What if I put an x cubed and an x cubed? That would give me an x to the 6th. X to the 6th, this is technically a perfect square because x cubed squared equals x to the 6th. Also, 6y to the 7th squared would be 36y to the 14th. So that's also a perfect square. So I might want to do a plus and a minus of a 6y to the 7th. And I think that's going to work. That should give us what we want. If we check this, we'd get an x to the 6th. And then the outsides, we'd get a minus 6x cubed y to the 7th. Then the insides, we'd get a plus 6x cubed y to the 7th. So those will cancel. And then the lasts, we'd get a minus 36y to the 14th. So that does give us the x to the 6th minus, x to the 6th minus 36y to the 14th. So that is the correct factorization. If we wanted to check and say, does that go any further? Well, the odd numbers in the exponents mean that these are not perfect squares anymore. The 6 is definitely not a perfect square, so we're going to be stuck at that point. If I tried, just for funsies, to say x cubed minus 6y to the 7th, does that factor at all? You know, if we tried to do any sort of mixing up, like an x and an x squared here, and then try and do something with the y's, the middle terms would not cancel no matter what we tried. If I did like a minus 6 and then a plus y to the 7th, no matter what combination, the middle terms will only cancel if we have the exact same thing with the plus or minus in there. So this is prime. All right, let's go on to the next one. And we have 9y squared plus 30yr plus 25r squared. And I see a couple of perfect squares at the beginning and the end here. I don't see a GCF, so I'll just start with trying the square roots at the beginning. That's 3y and 5r. And a 3y and a 5r. And we want these to add to a positive 30, so I'll try a plus for both of these. So give us a 9y squared for the firsts, and then the last would give us a plus 15ry or yr, stick with the same order as the original problem, and then a plus 15yr and then a plus 25r squared. These do add up to 30yr, so we're good. That is the correct factorization. And none of that's going to factor any further. No GCFs, no squares or anything to be able to factor. All right, one more, finish off this video on this topic here. We're going to, I see it so quickly I need to slow down. I see 4 terms. So when I see 4 terms, I think grouping right away. I might also say, could I combine like terms? And there aren't any. We have an xy and a 2x, but that 2x doesn't have a y, the 8y doesn't have an x, and the 16 is the only constant. So look at grouping the first 2 and the last 2. If I group the first 2, I can pull out an x, and I'm left with a y plus 2. And in the second 2, there's a GCF of 8, which I can factor out and be left with a y plus 2. That's nice. The y plus 2 is common, so we can pull that out to the front. When I do that, I'm left with an x in the first term and a plus 8 in the second term. And then that's it. We can't factor that anymore. So we are done there because y plus 2 is linear, x plus 8 is linear, no greatest common factors, so that's it. All right, everyone, that's it for this video. Thank you so much for watching. See you next one.